Hey everybody. I've had some comments and some requests from people who've been following my channel. Regarding diagnostic, I've got a car tuned port and it doesn't run right. What do I do? And I've been, I've made some comments and I've tried to help a little bit. So I thought maybe it was time to take a deeper dive into how do you diagnose one of the General Motors OBD1 early 80s to mid 90s cars. What should you do? If I had a tuned port car and it doesn't run right, what are my options and how should I attack it? And that's where I want to go today. And I'm going to kind of dig in quite a bit. In 1981 or so, I believe it was 81, GM went across the board with computer control systems, whether it was carbureted, fuel injected, you name it. And things were very consistent, I'll call it. They used similar strategies, whether you had a closed loop controlled carburetor or an electronic fuel injection. You still had an ECM and you had sensors, and each model, each engine was different, but you kind of could attack them in similar manners. So I'm going to dig in a little bit. Again, this is, I got a tuned port Camaro, and that's, if I had a carbureted V8 Buick from the mid 80s, I'd probably, consider the similar things. And, one of the consistent themes is that, no one knows how to work on these cars anymore. The mechanics today aren't trained in how to fix a 1980s car. I have an uncle that's, he's got a, oh goodness, I think it's an 81 Cadillac with the 684. And he can't find anybody to work on that either. And it was running really poorly, and he's had to park it because he can't find anybody to work on it. And if it wasn't that he's, 1,000 miles away, I might go try to help him out. Still might at some point, but right now, there's nobody that knows how to do it. I'm going to walk through this in some detail. This will take a little while, but hopefully you get something out of this if you're having trouble as to how you could work through and solve some things. I'm going to go through is, what are the basic control systems and electrical systems. I'm going to go through, where do you begin? Where should you start? And what tools do I need to do this job? Because when you walk up to one, it's kind of intimidating, okay, what am I going to do first? I've got all these computers and modules and wires and how does it all work? I'm going to start with tools. The first thing you really should have is an official General Motors shop manual. There are third-party manuals out there, and I don't want to, if you can find one that has the wiring diagrams and the trouble trees that come out of the GM shop manual, hey, I'm fine, no problem. But I'm going to start with using the official manual because that's the root. And again, if you can find somebody else, I've seen some things advertised on eBay where people have CDs that claim they've got them. I've never checked them out. Maybe they're good. All these manuals in hard copy are pretty much, they're out of print, so they're going to be used. But there are places, the one that I have here behind me that I've been using is a manual I picked up on eBay several years ago when I got the car. And it happens to be the loose leaf version, which a dealership could use because they could change pages in and out as you had updates during the course of a year. And then when the model year was done, all the updates went into a bound version. Also, I can suggest if you don't want to go sorting through eBay, there's a place called booksforcars.com. I know the owner because I worked with him at GM, goodness, like 25 years ago. And he left the company to go into business. He was buying and selling service manuals particularly for odd and rare cars. And he's expanded his business, and I've been on the website. And I know he has shop manuals and owner's manuals and all kinds of literature for Camaros. And it would be a good place to start. I'm sure there are other companies. I have no business. I'm not directing you there because he pays me or anything. There's no business referrals, I'll call it. I just know I have seen things on his site. I've been out to it. The second thing you need is a good digital voltmeter. This is my digital voltmeter. It's a Klein Tools. You can buy these actually at the home center stores. They're very, very important for doing diagnostics. One of the things that you'll find is that in this era, there were scan tools being developed. GM had what they called the Tech 1. They had a scan tool, but you couldn't just go down to your corner store and buy one. Electronic systems were new. So the service engineers, they did a lot of things so that you could use commonly used tools to diagnose the cars. Sometimes it was cumbersome, sometimes it was difficult, time consuming. A scan tool would be a whole lot easier. But they did a lot of things that you could do with voltmeters. So scan tool, I'm going to say a scan tool is optional. You don't have to have one. But boy, it makes life a lot easier. When I did this Camaro, the first engine was really a problem. It died, it had a cracked block. If you go back and look at my history and my videos, it was a sad thing because I got it all together and then it wouldn't run. And I tried using my voltmeter and I was trying to diagnose this poor engine that was fumbling all over the place and stumbling and hardly running. And so I went out and bought a scan tool. That's the Actron, 9690. And that helped me a lot. In the end though, the scan tool was of limited use there because the problem was not electrical, it was a basic mechanical problem, right? All the cam lobes are going flat. And so my message here would be, when you're doing this diagnosis, I'm talking today about control systems and how the engine is controlled and how you can diagnose that. But if you got a hole in a piston, I'm being exaggerating. Right? If you got a hole in a piston, all of this goes out the window. You need a sound mechanical engine. It's got to have compression. It's got to have all the basic stuff. And today we're talking control systems. Going back to digital voltmeters for a second and using this one. I say digital and not analog. You can find some very inexpensive analog, and when I say analog, that's the ones with a meter with a needle on it, okay? The standard that the controls engineers say is they usually want 10 megohms of input impedance or more. And most of the analog meters with standard circuitry, unless they're very expensive and sophisticated ones, the last one I saw, they're 2,000 ohms per volt or 10,000 ohms per volt, and they're nowhere near 10 megohms. Typically, if you get to a digital one, you can almost be assured that they meet that 10 megohms. They'll usually say it in the specs, but I've also seen, even this meter, when I looked, it doesn't say that it is. I think because these meters are so common. And why do I say that you need that? You want to be able to connect your meter to a control circuit, and you don't want the meter to change the characteristics of the control circuit. If you put some of these analog meters on there, you'll put a load on the circuit and you'll actually change the voltage in it. It'll start drawing current off the circuit and you'll change its behavior. So you want to have a high quality, and these things aren't that expensive. I'll say under $100, right? $50, $75, $100. I bought this one at Home Depot, and this one is actually a little fancier in that it's got a thermocouple you can plug in and put the thermocouple on to things and measure temperature with it. Also, it measures capacitance. You'll rarely need that for this diagnostics, but it's in there if you had a capacitor you wanted to check. And there's one other one called duty cycle, frequency and duty cycle. There are many things on the engine that are done with pulse width modulation, and duty cycle is sometimes a handy thing to have. It's not essential, but it can be helpful. So when you get one of these meters, it'll measure voltage. That's pretty straightforward. Think of the analog of a water pressure, pressure in your house, right? Piping. Voltage is the pressure. Amp amperage or amps, the current flow, is how much water is flowing through the pipes. Resistance is, hey, I crank down a valve, right, and slow that flow down, and it builds pressure up behind it typically. And that's measured in ohms. And as you go through working on the car, typically you're going to be trying to measure voltages in circuits. And you're going to be measuring resistance, ohms, on circuits and on sensors. Scan tools. This is a code reader. And you can buy them, a lot of places sell code readers. If you look in the end of it, it's got 2 terminals, and that's it. Well, the basic diagnostics on a GM car in the OBD1 world was there are 2 pins in the connector under the dash. And those 2 pins, and my memory is they're designated A and B, but you basically jumper across those 2 pins and it tells the ECM to flash the check engine light and give you codes. And the standard code you'll get is a 12. If the engine is off, just key it up, plug one of these in, you'll get a 12. Well, a 12 means there's no crank signal, there's no speed signal, the engine's not turning. So it'll flash 1, be a pause, and then it'll flash 1, 2, and then it'll wait. It'll come back and flash 1, 1, 2. It's a 12. So all of the codes can dump out this way, and then you go to a chart and see what codes you got. Most of us, I never bought one of these. I got this one from a estate sale for next to nothing. You can dump the codes with a bent paper clip. You just have to know which 2 terminals to pick, and you can look at your service manual and it'll tell you which ones you have to jumper. In addition to dumping codes, jumpering that will also turn on certain service modes. The ECMs have, depends on your model, but there's a field service mode on this tuned park car that when you jumper the system, it will go into, with the engine running, it will go into a certain mode where you can get other information. I'm not going to dive that right this minute, but so this is, when you go looking online, that's a code dumping tool, so-called code reader. OBD2 cars have code readers, but when you go to OBD2, let's see, codes are like 5 digits long, and the old jumper, the system, doesn't work so well. So the second thing is a real scan tool. Mine is this Actron 9690. Now I've had it for a couple of years. It works pretty well. It's not perfect, but it works pretty well. I was actually looking online as I got prepared to make this video, and every place, these seem to be out of stock everywhere. They don't say they're discontinued, they don't say they're not available. I looked at some of the stores and online, and they're talking about, well, you can't get it for a couple of months type of thing. So I don't know if it's something in the supply chain, but if you can find one on the shelf somewhere, I know that this works. Actron is a company that's run by Bosch, owned by Bosch. I went to their main site and they have a tool they call OBD1300. It's a Bosch OBD1300. And it looks a whole lot like this tool in a different color. I can't say that it's identical, but you might search that. The third one is, and I had looked at this one once before, is there's a company called Innova, and they had a 5512 that advertises OBD1 capabilities and comes with cables and so forth. And if you really luck out on eBay or something, you might find an old used GM Tech 1 tool that somebody's selling. Back in the day, those were horrendously expensive, but there may still be some out there. And also I would caution that you check the model year coverage. This Actron one says it goes back to 1984. If you had a 1983 Camaro, I'm not sure. It might still work, but you just don't know for sure. On the other end of things, when you get to 1994, 1995, GM started, and probably other companies too, OBD2 came in by law in 96. And so the companies started in 94, 95 putting out cars that were legally OBD1, but they actually had OBD2 diagnostics and diagnostic connectors. We had one in the family. My daughter had a 85 Buick Regal that had a 3800, and it had the new connector, and it had all the OBD2 diagnostics. And that car was actually kind of a bear because the OBD1 tools wouldn't work, and the OBD2 tools, it was a little bit of a challenge. The basic system that GM used from like 1981-ish to that 1995 time frame, all the systems have an ECM or PCM. The ECM is an engine control module, PCM is powertrain control module. People will sometimes use either designation, and they call it PCM powertrain because you have transmission parameters in there, even on the IROC, right? The converter clutch, certain transmission solenoids map back and are controlled out of the engine controller. Now the ECM, a number of things. It's kind of got three levels that you need to go look at. One is it does 12 volt feeds. I mean, you feed it 12 volt ignition power, and it has some 12 volt circuits, like to run the relays for fans and fuel pumps and such. Secondly is 5 volt sensors, 5 volt circuits to drive sensors or read sensors and drive outputs. So you'll find some of those. And then you got special circuits like oxygen sensors, which are really, from a wiring standpoint, really very sensitive, because oxygen sensors operate around 1 volt and at very tiny current flows. And then the last one is something called pulse width modulation. One of the ways that the computer does variable things like fuel injectors is by varying the pulse width, and the pulse is a square wave. Okay? And the system will vary the length of time that square wave is active. And it can go from like 10%, which is a very narrow square wave, to 100%, which is continuous power, full time. And so the ECM has drivers that will drive those kinds of PWM circuits. Getting a little bit more into the basics of GM's computer-controlled engines. They had several different terms, but usually they called it computer command control or something similar, depending on the variant and then the nameplate. Sometimes they would use different names. But if you look at this first slide, it's a pictorial of an engine, and if you look in the center, you have an engine. It's fed by a fuel system, and the fuel system could be a carburetor with a mixture solenoid on it now, a throttle body injector or port injectors. You have an ECM, an engine control module, that controls the fuel command, and it controls a timing command to the distributor. And in some cases, some of the later engines have in different models. Some of them have coil packs and ignition modules in their distributor list, but for the sake of this discussion, let's talk about they're still the most common. A distributor gives you a spark down to a spark plug, lights the fire, the engine turns, exhaust heads out, goes through a three-way catalyst, and goes out to the exhaust. Now, in order to make all this happen, you need a number of sensors. And so you'll have each engine, depends on which engine you have, they'll have coolant temperature sensors, manifold temperature sensors, speed sensors. Now, speed sensor could be crankshaft, or it can be picking up the speed out of the distributor. You have some engines have MAP, manifold absolute pressure sensors. It's like vacuum, except instead of a negative pressure, it's the positive pressure of atmosphere. Throttle position sensor, so you know how far open the throttle is. Some engines have a mass airflow sensor. And there are kind of two strategies. One strategy is to measure the air coming in with a mass airflow sensor. The other is to estimate the amount of air coming in, knowing the characteristics of the engine. If you know how far open the throttle is, throttle position, and you know what the pressure is in the manifold, you can estimate how much airflow there is, and those things will tell the ECM how much fuel they need to add in order to get the right mixture. Also, I mean, the real fundamental reason why all this was done is this three-way catalyst down here. And the whole mission of this is, for a three-way catalyst to work, it has three different pollutants it has to reduce. Hydrocarbon, carbon monoxide, that's what the old catalyst did. When you went to three-way, they added nitrogen oxides to the mix. And in order for both sections of this catalyst to work right, you need the mixture as close to stoichiometric as possible, which means 14.7 to 1. There shouldn't be any extra oxygen, and there shouldn't be any extra fuel. You want it right down the middle. In order to do that, you put in an oxygen sensor, and when there's too much oxygen, the ECM will add fuel. If there's not enough oxygen, the ECM will cut back fuel. And the goal is to get it so you have just enough air to burn all the fuel, not more, not less. Now, when you go to start the engine, or you do other things like run at wide open throttle, then there are overrides, and you don't run at that stoichiometric. So when you first start the car, your catalyst is cold, your oxygen sensor is cold, they don't really work. So now you're kind of back to old school. You need a rich mixture to light off, fire it, get it started. And then as soon as it warms up, they try to get it in this, what they call closed loop mode. And closed loop means that I read the oxygen sensor, I see how much oxygen's in the exhaust, I feed that signal back to the ECM makes the calculation, and it goes back to the carburetor, throttle body injector, port injectors, and adjusts their duty cycle to feed more or less fuel into the engine. You burn it, it comes back out to the oxygen sensor, and it makes that correction. And it's doing that correction many, many times a second. Then, that's just to get emissions. Now the engine has to perform, so now you need to control all the other factors. And so you'll have timing advance. What's the right timing advance? And to get the spark in the right place. Then we add the complication of EGR. One of the things in the emissions world is that nitrogen oxides are formed when the flame temperatures get too high. So the best way to reduce flame temperature is to take a little bit of exhaust gas, run it through a valve, meter it through a valve, and send it back to the inlet and run it through a second time. And there are some engines that don't have EGR. If you have the right combustion process and perhaps the right cam overlap will give you a little natural EGR. But most of the systems in these early cars have an EGR valve and they meter. But that's really only at cruise. At wide open throttle, generally the EGR is out. At idle, it's out because the engine won't run worth a hoot when you're starting or trying to idle. Then, going to this three-way catalyst, you have this air pump, and it's called AIR, air injection reactor, but basically it just pumps air into the exhaust. Now my picture's not perfect because I didn't get the arrow. This arrow should be upstream of the oxygen sensor. In real life, the oxygen sensor is normally downstream, but at certain times, like when the engine's cold, you want to put air in upstream here before the oxygen sensor's hot, and you'll burn up residual fuel in the exhaust manifold by putting air in. And that'll make things hot and it'll help warm up your oxygen sensor quicker. Then this three-way catalyst, even though it's three ways, it's a dual bed. It has two beds, two bricks, two sets of catalyst. And so you put air in between at certain times to get both sets of the catalyst operating properly. And in some cases to protect the catalyst from overheating if you're running a lot of wide open throttle or certain malfunctions in the engine. The AIR system is programmed to respond to those. So finally, some other notes is just depending on the car you get, this is why you need a service manual and you need to look at what you have. Some of the cars, especially the early ones, still had vacuum advance on the distributor like an old one and mechanical advance. And the ECM actually didn't control timing. It was all built into the, just like before you had computers. And all the ECM did was control the fuel mixture solenoid on the carburetor. Each engine is different depending on the progress between, when this started about 1981 through 1995. And the later cars, the further you go along, the more likely you are to find electronic spark timing. The carburetors are much like the original carburetors, except you've got this mixture solenoid. So, if you're used to carburetors, don't let them scare you. They've got float levels and all of the things just like they always used to have. But you have this mixture solenoid that compensates and adjusts fuel mixture. It will adjust fuel mixture in open loop as well as in closed loop. It does have a program. But recognize that's your fuel adjustment mechanism. Otherwise, if it didn't have that, it would be just like an older carburetor. And I've already mentioned that you may have a MAF sensor or you may have a MAP sensor, and the strategies are different. If you have a port injected or a throttle body, you have an idle air control that will allow electronic control of the idle speed. Generally, the carburetors don't. They may have an idle load compensator, but it's not as sophisticated as the stepper motors and so forth that are used in the IACs. So if you have a carburetor with a mixture solenoid, you can repair that pretty much. You can do carburetor rebuilds just like you always used to. You just have to be a little extra careful not to disrupt some of the settings around the mixture solenoid unless you have the right gauges. Again, follow the service manual or the repair instructions. Throttle body injection, port injection are two different animals. Throttle body just runs with the injection at a central point, and it tends to run at a little lower fuel pressure than port injection does. Port injection runs at higher pressure, so you get the fuel fed right at the intake valve typically. Now, service manual. Why do I want you to get a service manual? Well, the first thing is it shows you the locations of components. There's a map on there that shows a diagram of under hood, and it will tell you where the different sensors are, where you can find the pieces. Next is it has sections with the general description of functions. It'll explain to you, how does the fuel system operate? What does it do? Why does it do what it does? They're fairly short descriptions, but when you're trying to diagnose things, it can help a lot. The biggest one is trouble trees. If you have a diagnostic code, you go into the manual under the code, and there are 1, 2, 3, 4 pages of a trouble tree, and you come down and you follow the logic tree. It'll tell you, do this. Did it respond, yes or no? The answer is no. Okay, go over to this branch. And if you take the discipline to follow the trouble tree through to the end, it'll lead you to the problem. In most cases. It gives you pinouts of the ECM, it gives you pinouts of the sensors. If you don't have a scan tool and you want to know if your sensor's any good, say a coolant temperature sensor, it'll show you the pinout in the service manual. You take your DVM and you put it on the resistance scale, and you go in across the pins and you read the resistance. And it'll tell you what the resistance should be if the sensor is, 80 degrees or 30 degrees or whatever. It'll give you a reference. And you can check and see if that sensor is doing what it's supposed to do or not. The service manual will also direct you into these other service modes. Some of them that you can do with by putting a jumper on. Some of them that you would do with a digital voltmeter. So the service manual, and it's kind of an intimidating document, but if you break it down and go to the section that you need and kind of ignore the rest of it, just burrow in on the section you need, you don't have to learn the whole service manual. You just have to learn the part you need for what isn't working. And then of course it gives you mechanical repair instructions. If you go in for the tune port, there's a whole section on working on the pressure regulator, the throttle body, it goes into the mechanicals of all that. And it has some special tests for things like air pumps and fuel pumps and making sure that all these things work. So it's worth having one. If you don't, it's kind of like going through the dark woods and with your eyes closed and not running into a tree. Okay, you gotta go after it. Now, some basics. Safety is a big deal, right? Some of these things, a lot of times when you're working on the electrical, you should pull the ground cable on the battery, right? And then you can touch things and you don't have to worry about drawing an arc. You don't have to worry about hurting anything, starting a fire. If you're going to do electrical diagnosis on the computer system, a lot of times you have to do it powered up because you need the sensors running. You really want to watch out and make sure you don't have short circuits. You don't want to get power to ground and draw an arc or blow a fuse or damage a circuit in the ECM. If you're probing with the probe, if you're probing with one of these guys, you don't want to get that metal probe across two terminals. Touch one, but don't dare touch two, because if you short across them, you're liable to fry something. Some of those circuits are pretty well protected, but some of them aren't, and so you really want to watch. And if you haven't ever used a DVM before, I'm sure there are plenty of places where you could learn how. But one thing is the ammeter function. It measures amps, measures current. Don't ever put that across power. You put an ammeter in line with a circuit, and you need to have some idea how much current that circuit draws before you do it. This meter is protected with some pretty good fuses, and you'll just blow the fuse in the meter, but I can't speak for everything you might buy. Now you intermittent. You want to be very careful not to create intermittence if you're working on the car. You want, on connectors, you don't want to ever force things into a connector socket to measure. You want to be very gentle. This is a weather pack connector pin. And if you deform that guy, then the pin that fits inside it may not make good connection, and you'll get an electrical intermittent. It's a very common thing. This is probably one of the toughest things. If you've got the right connector, these are my jumpers. I've been carrying these dudes around for 30 some years. These are a weather pack pair that I just made up with a piece of wire. I went down to the dealer and bought some weather pack connectors. And if I'm going to, these specifically were for checking TPS when I didn't have a scan tool. I could go onto a TPS sensor and plug these in and take the wiring harness off the TPS sensor, put these in line with it. I have 3 of them, and then I could clip my test leads onto these connectors and measure the voltage and make adjustments to the TPS sensor without trying to probe into the wire or without trying to probe into the connector. Now, ECM, PCM, in these cars, almost always, it's in the passenger compartment. The ECMs weren't hardened, I'll call it, to be able to take the temperatures that you get under hood. So they'd put them in the passenger compartment usually on the passenger side, up under the dash. And there were different places. Some cars would put them in call it the kick panel off on the side, and some of them, the Camaro, the IROC, you take down the panel underneath the dash on the passenger side, and the ECM is held up on a bracket up underneath there, and you take a couple of bolts out and you drop it and its wiring harness down so that you can get to its connectors. If you have a scan tool, you don't need to go there as often, but once you get the ECM down, you can take your voltmeter and you can probe the connections, and if you go back and check your service manual, the service manual will tell you what the voltages should be on each one of the connector pins, and you can back probe those things. Also, the ECM on a tuned port car has a PROM in it, PROM, Programmable Read-Only Memory, and that's the calibration for your car. And you could unplug those and plug them in, and if you have the right tools, you can even reprogram them, but that's a whole separate topic. But you need to have the right one for your car. But that way you could use almost any ECM, ECM for your model year, and there might be 24 different PROM combinations, and they would use the same ECM and you would just plug that in. Later years, as you got closer to OBD2, they started to get into electrically erasable memory and flash memory, and today, you flash a car with a tool through the diagnostic port. The PROMs, so to speak, the memory is soldered into the board and it never comes out. You just, like I say, you program it with a computer tool. But for the IROCs, you got for tuned port, you got a PROM, and I don't know when they got to 1991 or so, whether you still had, just be aware. One of the biggest problems that you'll get in a lot of issues with an older car, with older computer controlled cars, all of these circuits are really critical that feed into the ECM. Just in principle, right? The 12 volt stuff's, it's pretty robust. You can have a problem with a connector with 12 volts, but usually 12 volts will arc across things and usually find its way to make a connection. When you get into sensor circuits that are 5 volts or less, they don't have as much punch, as much power behind them, and so they're very much more sensitive to the connector. In the early 80s, there tended to be, there's several things. One is, you can have a pin that's damaged. It can be dirty. Sometimes just cleaning them with electrical cleaner. Sometimes they're corroded. It's kind of like micro corrosion. There's a phenomenon called fretting corrosion. And in the early 80s, I never ran into it too much in GM cars, but I had some other brands where you really had to be careful, because sometimes if you had an ECM, if you just unplugged the connector to the ECM and plugged it back in again, it would, I'll call it, wipe the connector a little bit, and it would work again for a while. And it would cause intermittence where cars would stall. And what happens is, it's a mechanism where if I'm trying to hold that in front of my face, and it's a mechanism where if you have a pin on a socket and it vibrates and wiggles, the two of them can build up a layer of corrosion from this little microscopic movement. And that little layer of corrosion will stop electrons from flowing, and you'll have an electrical intermittent. And so you want to take those apart, clean them, put them back together. You want to make sure they're not loose. You want to test them for drag. And again, if you go to the service manual for these weather pack ones, they'll advise you that you can crimp on them a little bit and you can fuss with them. You maybe can try that, but be careful. You want to be able to take the pin and slide it into the socket and feel it go together, and it can't be loose, and it should have a consistent drag when you pull it apart. And the second one is, if you look at the sides of these, see these little tangs on the side, the little metal prongs? Those, when you put this in a plastic connector body, those prongs keep that from backing out. And if those prongs are bad, bent, abused, whichever, and that backs out, you won't get good connection from the pin that's going into it. Third one is, you can have a bad crimp where the wire goes into here. And these didn't have a fancy crimping tool. It was a do-it-yourself. But you can go into a connector, and if you look at the service manual, they'll usually show you what kind of connectors you have. But you can bend the tabs and back that wire out of the connector, and you can replace the pin. I'll tell you, just from experience, in my recent years, we were working on hybrids, and I would get new cars coming out of the prototype shop. They'll build a brand new car, right? It's 2 years before production, 3 years before production, and it's built in the prototype shop. And of course, these are OBD2 cars. They'd start setting check engine lights, and they'd have intermittent check engine lights or check hybrid system lights, right? And I would be ready to go call up the engineer who owned the parts that were connected together that were faulting out. And I had a couple guys on my team who were really good with this. And they'd go, hey, stop, wait, let us go through the car. And they would go through the whole car, and they would pull all the connectors, and they would go through, and they're not, I mean, these are weather packed, they had many others, but what they would do is get a bare pin or a bare socket. They would go through every connector that was related to the fault, right? And they would check, like I just showed, they would check for drag. They would make sure that they pulled correctly, that they had the right tension on them. Or that the connector one of the pins hadn't backed out of the connector. And I'll tell you, 9 times out of 10, they would find a backed out pin, or they would find a deformed pin that's just somehow in the process of doing things in the lab, that one of those connectors wasn't making good contact, and the OBD would pick it up as an intermittent. I'll say is on OBD1, like these cars, those diagnostics weren't as sensitive, and you may not get a check engine light, but you may still have an intermittent connection. So in some cases you want to just get them to test with, and if you don't want to do your own repinning of connectors, there are different aftermarket companies that sell standard motor parts, socket and pigtail assembly. This is one for one of my fuel injectors. I have one that has a cracked body, and I was going to put in a new one. But you end up with a connector that's got the pins in it and a wire, and then you can splice that into your regular wiring harness. Now, if you go splice one in, either wrap the wire and solder it with good electrical solder, and use shrink tubing, heat shrink, that's waterproof. They make them with kind of a gummy glue on the inside, so you put them in and use a heat gun. Or you can buy butt splices that you can crimp also that are weatherproof, that you heat shrink them after you're done. But you want to keep water out of those, because you don't want to fix a connector and then have corrosion and have that fail again. So where do you want to start? I've been talking for a while, but where do you start? First, I would go in and check for diagnostic codes. there are active ones, and then there are, history codes where, on these cars, the light will come on if you have a problem, and then the light will go off, and normally the ECM will store those for a period of time. So the first thing you want to do is make sure you're clear of codes. If you don't have codes, I'm going to ask the basic maintenance question, right? Are your fuel filters cleared? Are your spark plugs, wires up to date? That doesn't mean you have to go out and change them. It's just, are they reasonable, right? Has it been a long time since you put plug wires on it? Long time. 5 years, 50,000 miles. You could have a bad plug wire in a couple of days, but just be aware that those things can be an issue. Distributor, cap, rotor, I'm going to call it all the basic so-called tune-up stuff. You might just pull the spark plugs out and take a look and see if you got a spark plug that's not firing correctly. I mean, the color would be, if it's fouled, you got a problem on that particular cylinder, right? If you have a code, and that code's consistent, and it's been setting, repeatedly, you go to the service manual and you follow those trouble trees. If it's intermittent, then you need to go to the section of the manual where it talks about intermittence and work through some of those. It will tell you don't follow the trouble tree if it's really a random intermittent type thing. And if you are into intermittence, then it's something we got to work through. On my tune port, now we're going to get right down to tune port. And a lot of these things you're going to see, if you go back and look at my earlier videos, you'll see where I've been working in these areas before, and they've caused me some issues. So, something to pay attention to. First is fuel pressure. Is your pump working? Is your fuel pressure, you can measure it at the rail with a fuel pump pressure checker, and make sure that your fuel pressure is correct. Injectors could be an issue. I don't jump to that as a conclusion. I would say try to run what they call top tier fuel, or use Chevron's Techron additive if you want to make sure fuel injectors are clean. I mean, injectors can be an issue, and you may have to look at, again, through the service manual, there are things to do to check electrically whether the injectors are correct and whether the drivers are firing them properly. High energy ignition. On these cars in that age, it worked pretty well most of the time. But I know from experience from my family from back in the day, it was not unusual to have the modules, in particular, start to get, I'll say, flaky. And if I had major troubles where it was not running well, I think the first thing I would do after going through the other diagnostics is I would probably put a module, get a good module, and replace it redo the distributor, clean it up. There are several things in there, and again, you can go back and look at my older videos, but the ignition module, there's a spark trigger pickup. Now to do that one, you've got to take the shaft out of the distributor, and that's a little trickier, but it's less of that's one that doesn't go bad as often. When I rebuilt this car from being stored in the garage for 25 plus years, I took the distributor apart and I did everything. I said I want it to run right the first time. So I put in a pickup, I put in the pickup coil, I put in the ignition coil, and I replaced the one that they call the radio capacitor, which is also inside the distributor. I think you can buy a rebuilt distributor and get the whole thing at once, but I would watch for the ignition module, because there were times where those could be intermittent and not always put out full spark. Watch out for vacuum leaks. Tune port had a reputation because of all the different places that you have up here in the runners. There are a lot of gasket surfaces, and you want to make sure those all seal. Also that your vacuum hoses are all connected, and that the hoses to the purge system, to the charcoal canister up here, are all good. And it may seem a little bit weird, you know, hey, why are you worried about the fuel tank and the purge system? Well, the mission of the charcoal canister and the venting system is to not let fuel vapors go out into the atmosphere. You want to burn them. Well, that whole system feeds those vapors into your engine and into the intake manifold. And if it's not working right, it'll knock your fuel mixture off, and the car won't idle worth beans, and it may stumble when you tip in. I've had it. It's a real thing. And it makes sense. Even today, with the car fixed, if I'm in heavy traffic, it's really kind of interesting, because if the car's hot, you know, you're in heavy traffic on a hot day, and you just crack the throttle just a little bit, that purge system will start to flow, and she'll start chugging a little bit, and it gets a little rough. It's like, and then you tip in a little further where it gets a little more air, and it clears all that out, and it's happy again. Sensors, you could have bad sensors. Any sensor in the system could go bad. You can measure those with the ohm meter. You can take your scan tool and you can read them live. And if you're dealing with intermittence, if you happen to be at a point where the car starts running really bad, you know, have your scan tool and look at it. If you have your scan tool, if someone's with you, you don't want to do this yourself while you're driving, but have somebody who watch the sensors and watch the response and see if something's not reading right. That could give you a clue where you might want to look. One thing I'll tell you on my 85 is, with this Actron tool, is that it doesn't always read each sensor exactly accurately. I had a coolant temperature sensor, and it reads like, I forget the exact number, but it reads like 20 degrees off. And I replaced the sensor thinking that the scan tool was good and the sensor was bad. And the new sensor read just like the old sensor did. So there was something in the calibration on the Actron tool was just not quite correct. And so it's just a caution. AIR system, the air pump. There are modes in the air pump where it's pumping air into the exhaust. All of these cars run a closed loop fuel system, right? So after the engine warms up for just a few minutes, it goes into closed loop. The oxygen sensor is reading the fuel air mixture coming through the engine and out into the exhaust. It expects air or not air based on whether the air pump is doing its job. And if it doesn't get what it expects, it will adjust the fuel mixture thinking that the air pump's operating normally when it's not. When you get into these cars, one of the things you have to kind of watch the most is the oxygen sensor. Again, I had a brand new oxygen sensor on this engine that went bad in very short order, became intermittent. It would work good when you were at light load, but if you got out on the road at, say, 50 miles an hour and it started heating up, it would fault out. And it would take quite a bit before the diagnostic would pick it up. The diagnostic needed you to be cruising at a certain speed for like 2 minutes before it would pick up and set a code. And a lot of times out here on the county roads, I wasn't running, before you had 2 minutes you had to make a turn, you know. But anyway, one of the things in the computer-controlled engines, the oxygen sensor is trying to read the air in the exhaust manifold. And if it's rich, it backs off the fuel to lean. If it's too lean, it adds fuel and tries to make it more rich. And its goal is to hit what they call stoichiometric of 14.7 to 1 air-fuel ratio, with some exceptions. But when you're cruising down the road, that's its mission, because it wants the catalytic converter to be running at stoichiometric for best emissions efficiency. That's the name of the game. If you get a misfire and you're sending raw fuel down the exhaust pipe, there's two things. In some cases, it may look lean because you're sending too much air because the fuel didn't burn. And in other cases, you send partially burned mixture down there, and that partially burned heavy carbon monoxide mixture may look rich. And in some cases it's counterintuitive, but you really have to watch, because something like a cracked spark plug insulator will drive your system crazy, because the oxygen sensor will pick that up, and it will adjust the fuel mixture on the entire engine and upset all of the other cylinders together. I had a friend, coworker in the 80s. He had a 4-cylinder car, and he took it to, they did a tune-up for him. He was heading from Indiana to Florida, and he got about 100 miles out of town, and this car started acting up. And he stopped a couple places, and they kept fiddling around. Nobody quite, his fuel economy was terrible. It didn't make any power. It was only about an 80 horsepower engine to begin with. He struggled down to Florida. He struggled home. And when he got home, he was a mechanic. When he got home, he got it and put it on an analyzer and dug in and found that he had a cracked spark plug insulator. One of the brand new plugs had a crack in it. And that fuel mixture being off, the computer system compensated by making everything else lean, and it made no power, and you had to tip in, and lesson learned. So that's my message for getting started. I'm going to show you a couple other things here. I'm going to go into the service manual and show you a few things there, and I'm going to show you where the code reader works, and a couple other odds and ends. All right, so here's what they call the drivability and emissions section of the service manual. The first thing you get out of that is the component locations. So you can see here, 15 is the vapor canister solenoid. Each one of these numbered locations, spark control module, fan relays, all of the different things, and some that are not ECM connected, but all the emissions components are called out here in this first section. This side, this is the ECM connector. So this is all of the connections on the back of the ECM. These are the voltages that you should get with the key on, and the voltages you should get with the engine running. Some of them, like IAC signals, you may not get a useful signal out of. They say not usable. But all of these different circuits, you can go back, if you don't have a scan tool, if you have this manual and you have a digital voltmeter, you can go in and measure and make sure that these voltages are what you would expect them to be. There's a section here called Diagnostic Circuit Check, and it talks about you grounding the test terminal, making sure you get the flashing code 12, the ability to go into the field service mode. Over here is is your first trouble tree. Fuel injection diagnostic circuit check. And here's a picture of the connector with pin B and pin A, the diagnostic terminal that you would ground. And you can do the field service mode by running the engine with that terminal grounded at operating temperature, and then it will give you, am I going into closed loop or not? Am I open loop? Am I lean? Am I rich? As I said earlier, without a scan tool, there are quite a few things that you could do if you just have some of the basics. They were trying to help you. And here's where you'll start. If I don't have a check engine light, you got a whole section of charts here in section A, along with the wiring diagrams. So, here's the ECM, here are the different terminals, here's what comes out, and what you can check and measure. If we go down here into the middle, here's code 43 on electronic spark control, and it shows you the circuit. It shows you what the voltages should be. Here's code 44 for lean exhaust. We'll go back a little further. Here's the section for intermittence. Right down here, and it's based on different symptoms. But there it says most intermittents are caused by faulty electrical connections or wiring, poor mating of the connector halves, terminals backed out, improperly formed terminals because they've been damaged, or poor terminal to wire connections. And I can tell you, from years in the business, that is a really big deal. We'll go to the back here. Here's my fuel pressure regulator instructions. But you can go in back here and it will, it shows you the fuel rails and how to service the fuel system, the throttle body. There's some stuff mixed in here for the 2.8. There's charts on the idle air control, on the canister purge system and how it should work, electronic spark. So there are charts in section A, there's charts in section B, charts in section C, but this whole 160 some pages is all important for you. Now, one that I've pointed out a few times before is right here. Get a good look at it here. This is the little valve with vacuum lines attached that controls the vapors coming off. This controls the vapors coming off of the fuel tank. And this one is on top of the canister is an electronic solenoid. But that one down below also controls the flow into the canister from the back. And then this hose right here feeds across into the intake manifold and goes up into the plenum. And so you purge out the fuel vapors that are in that canister and burn them. On my engine, this one has the original fuel injectors. I pulled them all off and I sent them out to an outside shop, and they went in and rebuilt these fuel injectors. I know there are some that also replaced them. For the amount of money I spent, maybe a replacement would have been better. But these are the original ones. They're steel. They're pretty nice, so I went ahead and kept them. Again, you want to make sure your distributor's in good shape. Your fuel pressure on the other side there. Fuel pump relay for the fuel system. This is your air pump system, and there are solenoids on there to make sure that air is sent back to the manifold at the right time. Your oxygen sensor is down here in the exhaust manifold. And I'll tell you, that wire is one of the more sensitive ones. You really want to make sure that has a good connection. Again, because of its low voltage. So for those of you who wonder, you can see here's the center console. And there's the OBD port. And I'll start by plugging in this code scan tool. And it just goes in the port like that, hangs out the end, and then see if we can power it up here. You can hear the fan takes off. And you can see that it's got one, two. So it's flashing a 12, which just says that the engine's not running. And if you had other codes, they would show up there. Okay, now I'm going to switch, and I have my Actron plugged in, and it's plugged into the same diagnostic connector. Normally that connector has a little cap over the top of it. I have the cap off and tucked away because I've been connecting off and on from time to time. It also needs 12 volt power, so you got to plug it into a cigarette lighter connection. And then when you turn it on, you get vehicle diagnostic screen. And you have to do a manual setup. For a US car, you select the model year. I go back a ways here. Pick a VIN F for TPI. Select a vehicle to replace. Yeah, I've got too many in here, so need the ALDL cable, which is plugged in, and the cigarette lighter cable. So I'll turn the key on. No codes. Data stream, view data. For this point, we'll look at the entire data list. So there we go. You can see the status for this third gear switch, the fourth gear switch. Coolant says it's 76 degrees. See, this was my comment about the coolant temp sensor doesn't read exactly right, even though I'm sure that it is correct. Brand new sensor, but this garage is maybe about 50 or 55 at best. And of course you can see EGR duty cycle, engine's off, it's lean, the fan is off. The IAC is 145 is like wide open, ready for a start. See, there you go, the manifold, the MAT sensor, manifold temperature, shows 50, manifold air temperature. That one's correct. That's about what we got in here. And the O2 sensor won't show anything useful because it's cold and there aren't any cross counts. But that's what you get out of the system. TCC solenoid and the TPS sensor's on 0.49. And we're all good. So if you had an intermittent type failure, I'm going to turn this off so it doesn't make so much noise. So if you had an intermittent type failure, you should be able to watch this screen with some, if you're driving, you want somebody helping you so that you don't crash the car. But you can watch all these different parameters, temperatures, and if a temperature sensor was going wacky all of a sudden, or if the oxygen sensor was not, you were in closed loop, suddenly go to open loop while you're just cruising down the road. There are, a whole number of things could show up here. This particular car won't show you what spark timing is, and the knock sensor has its own module, so I can't read that. So there are some things that are limited that maybe in later models would be more helpful, but that's what the scan tool will give you. Now finally, I'm going to go down here underneath and say, the passenger side of the dashboard. When you come down underneath here, there's a panel here, and you have to come underneath here and remove that panel to get to the ECM, and then it mounts vertically up underneath there. That's what you would need to if you wanted to pull it out and get to the terminals. Well, I think that's about all for today. I hope I've helped some of you in understanding what it takes to diagnose one of these cars. I would say don't be afraid of it. Get the tools, get the book, and work through it, and ask for advice. I mean, certainly we can continue, but you kind of got to dig in, and then work your way through issues. And it's possible to make these run well. It's doing good and it's been reliable, and I haven't had to touch the control system. I mean, it's 5,000, 6,000, 7,000 miles. I mean, I don't put that many miles on it because it's not a daily driver, but it's running well, and yours can too.